Live from New York, it's Ask This Engineer.
Hi, everybody. Welcome to Ask This Engineer. It's me, Ladyada, with me, Mr. Ladyada on camera control, and beamed us into the Tron Matrix, it looked like. We fight for the user. We've got an exciting show tonight.
What's going on?
Lots going on. Let's get right into it. What's the code? What's the news? What's going to happen in the next 50 minutes?
Yeah, so the code is EtherWiz, 10% off in the Adafruit store, all the way up to 11:59 p.m. Eastern Time. User to lose it. Please, go and save $1 or $2. We'll talk about what was on Desk of Ladyada over the weekend and more, including the great search. We have a highlight from JP's product pick of the week. JP's off next week, so get your JP while you can. And then Lady and I are going to talk about what I think is the biggest story ever in open source and open source hardware that you probably don't know about and won't hear about. We'll see. 3D printing. We got, this is a mailbag, but it was more like, hey, this is a cool thing I saw on Adafruit, so I'm using it as a mailbag.
This one.
New product introduction.
As always.
NPI. TI's back. Texas Instruments. Lady is going to show something cool, and you know what? It's brought to you by DigiKey, of course. We got some new products. We got some top secret. We got a bunch of top secrets. So much so I didn't even have time to do the 2 videos. So I think we're going to do these top secret videos as regular videos later, and we're going to just do the regular old top secret that you cranked out. You did 1, 2, 3, 4, 5, 6 boards.
Okay.
We're gonna answer questions. We're over on Discord, adafruit.it/discord or discord.gg/Adafruit. That's where we do all the questions and more, but you know, we answer them throughout the week. Just somehow tag us and we will see it. All that and more on, you guessed it, Ask an Engineer. Okay.
Beep, boop.
Go to EtherWiz. You get free stuff when you check out. We also have same-day shipping. Let's get to a little bit of a recap of the week. We did Desk of Ladyada on Sunday. Ladyada, what did you talk about on Desk of Ladyada, part 1 and part 2?
Okay, I mostly talked about nudes. I showed some nudes.
Yeah.
So go there. You can watch my glowing nudes and constant current boost converters. I showed up some designs that I've been working on, just some sensors. We'll show those as top secret. And then for the great search, I looked for UV LEDs that would be good for illuminating costumes that have like fluorescent paint on them.
Okay.
That was the show.
All right. And then JP's product pick of the week. It's every Tuesday. It's inside the product page. Discount automatically applied. Let's play this week's highlight.
It is the Feather NRF 52840. It's a feather that is great for Bluetooth Low Energy or BLE projects. It's compatible with a whole bunch of feather wings. You can add displays, inputs. This runs CircuitPython. It runs Arduino. You can use our Bluefruit Connect app as an interface. And now if we go to controller, these are all phone streaming data. So if we go back to accelerometer here, you'll see X is at about 0. So you can send that data, stream that data over Bluetooth. I can shut that off. It's still sending Bluetooth. I'm also printing out that data here to the REPL. So I'm just saying, okay, what accelerometer data is coming from the phone? And then let's just highlight that roll value, that X roll value, which is what I'm using to light up the LEDs. That right there is the product pick of the week this week. It is the Feather NRF 52840 with BLE.
Okay, and JP's off next week, so you can just watch some of the other shows. We do 3D Hangouts every Wednesday. You can learn how to make all this neat stuff that you're going to see later on in the show. And then Friday, Deep Dive with Tim. Tim's working on a bunch of projects. Some of them are things that I wanted to do, but I get to work with people who do the projects. So you'll see some fun collabs between, let's see, JP and Tim, maybe me and Tim, maybe Tim, all that, and more. So tune into that on Friday at 2 p.m. Pacific, 5 p.m. Eastern. And now we're just going to jump into a big topic that we'll see what happens in the chat and more, because this is interesting. So let's go on a journey, Ladyada. Do you remember this?
I remember that.
You remember this?
It's like 2016.
Yeah. So this is Chris Anderson on the cover of Popular Mechanics magazine. And this is Jordy on the cover of Make magazine.
Wow, what were they working on?
They're working on drones.
Wow, how cool is that?
So I was talking on an email a long time ago with like Tim and Dale from Make and O'Reilly. They published Make, and we have history, and Tim was saying like, oh, Phil, you should do some like Wikipedia entries about the maker movement and stuff. I'm like, oh yeah, I'd like to do that one day.
Yeah.
Like people in the maker movement, there's been such a story and things have been going on for so long, but not a lot has been like captured because I think the people doing this stuff don't have time to necessarily talk about the stuff.
Yeah.
So I think that's why like this might have kind of been a surprise, so what I'm going to talk about in a bit. Because how long has it been since we talked about DIY drones or ArduPilot?
It's been like 10 years.
Yeah. So just a quick thing, just to give you an idea of like how weirdly interconnected open source is and all these things. When Limor went to this photo shoot, the Popular Mechanics Makers photo shoot, the way they did it is they shipped the stage around the country, and these famous makers, 25 leaders of the new industrial revolution. You were one of them. Chris was one of them. And
There are a couple other people there too.
yeah, there's 25. And when you fold out the spread, there's Bree from MakerBot, there's Beth Comstock from GE, there's Ben from Quirky, there's you from Adafruit. And we saw Bree there. And I remember seeing Bree, and there was a
He said there was a documentary.
there was a
coming out soon.
documentary crew with them, and I said, neat. Is it yours or someone else's? And he said, someone else's. And I go,
But don't worry, it's going to be really great.
I said, oh my God, I'm so sorry. And I said, you got to stop it. So this eventually was Print the Legend, which was on Netflix. And it was like an edited documentary, which you can edit any way you want. So all documentaries, even like I think the honest ones, cut the documentary in a certain way to make
Of course they do.
people look a certain way. So it's just like, that was like that peak of Makerland. There was like a documentary crew, and there was like,
Well, let's put it this way. People who do documentaries don't usually change what the documentary is about halfway through videoing. They already have the documentary.
they already decided.
They already decided what the story's about.
And you know, they went after Brie, and it was like, so it's like that's what they decided, I think, already before.
Yeah.
But anyways, in this one magazine, like captures so much that was going on. We were selling the 3D robotics drones that Chris had in his company. Chris had a USA startup making drones. Imagine how things would have turned out different if that was still around. So anyways, so we were writing about, we were doing all this stuff. When you go to the Adafruit blog, which you should, when you go to the Adafruit blog, we have a bunch of content from the years and years and years of showing what can be made with open source hardware, what can be done with open source hardware. So let me go to our page here. So you can just see, this is 2011. I wrote about the cloned.
Wow, I thought it was 2015, but I guess even earlier. This was like 2011, 2013. This was like the
so you could see
peak.
May 19th, 2011, Chris Anderson talking about 3D robotics, and there's DIY drones, and the hardware was getting cloned. And that was a problem for them. It had nothing to do with open source, really, but clones happen, whether you're open or closed. Flying Robots NYC meetup. Then you have all the ArduPilot stuff we covered over the years. And this is just me. I think I typed ArduPilot. There's a ton of other stories.
Yeah.
This is just like WordPress search on here. So you can see like over a decade plus of things going on this project. Cool. During Open Hardware Month in 2019, DIY Drones has one of the biggest communities. I'm like, that's worth mentioning. It's Open Hardware Month. So they had 91,000 members.
Yeah, it was massive.
Massive. Still there. There was a case study. They were using like what was that software to manage their company back in the day? Where is it? There was a case study on it. It was like the biggest way to do stuff. It was called, I don't know. It was
The website? Yeah, I don't remember.
you remember
Was
there
it
was
a
like
wiki?
everyone was doing that community stuff, and it was cold. There's a case study on it. Did I put it in here? Yes, I did. Ning. Remember Ning? Ning was like going to take
Ning.
over.
Oh, yeah. Wait,
So-
Ning, did they get bought by Mozilla or something?
Who knows? Let's see what happens when I click Ning. Hey, look, they're there. Look at this.
Wow,
It's still there.
they're still there.
It's nice. Okay. So this is the community here, creator since 2007. So this is when Chris registered all this. And it's nice. Boop, 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 boop. Okay,
Wow.
cool. This is when he started.
I'm surprised that they're still around.
Yeah, that's cool. So next up, what else is there? Well, you could see at the time, I did a snapshot of 2011, and this is when the internet was a little different.
Yeah.
You can see how Google worked. There was no AI at the time. There's a Wayback Machine link. That works different now. The earliest screenshot that I could grab was from 2007 for DIY drones. And at the time I wrote about this, Chris was running 3D robotics, DIY robocars, DIY drones, drone code. He wrote the long tail, free makers, editor-in-chief of Wired. He put Lamar on the cover. And you could see like this giant community came together. We were doing films and stuff like that with drones. These are our drone films. We did 2016, 10 years ago, we did the Adafruit dronies. And I got dinged because all of the judges happened to be women, but it wasn't on purpose.
It was actually just a coincidence.
It was a coincidence. It's like,
I mean, come on. Daniel Applestone, Other Mill. Danielle,
these are all people who did stuff. Yeah.
Christy, who was running Instructables.
Yeah, this is all people who
Anna
did.
Lee, who was like one
Helen
of the top,
Greener,
who was running IO9.
who was the co-founder of
Woman
iRobot.
scientist.
So I remember when someone
Liz
said,
from Raspberry Pi.
yeah, so I remember when someone said,
I was even part of it. Obviously, if it was all women, it would have had me, but I wasn't in it.
So this is like
obviously it wasn't like some
this was a neat
engineered
snapshot
thing.
in time. Like 10 years ago, it was problematic to be a woman doing technology on the internet.
Yeah.
Now, just everybody hates everybody. It doesn't matter if you're a woman or not. So we also had to get permission to use Droney because Twitter, for some reason, had the trademark. Whatever.
Yeah, I don't know.
It was a wild time. And look, you could check out all of the designs that are on Amazon at the time that happened to be cloned.
Yeah.
Here's the right firmware for
From the ARM, the STM F427.
Pixhawk is a registered trademark. Is it anything that they could do? No. Who knows? And then at the time, it was interesting that Lamar was on the cover of Wired. And I took photos of what we celebrate in America at the time. Snooki, you know.
And making stuff.
And making stuff. And if you think about what's happened since then, from this new thing, Russian army being smacked around by drones that are run by this open source software project from 20 years ago. So this is like the history. And now before I go into, hey, Ladyada, let's talk about some tech, I've got the clip from CNN, and then I've got photos of this thing that happened, which is open source being used for the first time to have these automatic things that popped out of a semi-truck.
Yeah.
And went and destroyed aircrafts before they could take off. No casualties. Interesting thing. I've got photos, and I'm not seeing this in like the US press at all, or really anywhere besides the people that are kind of in the know who've known about
So
this.
these are like, I guess, DIY. I mean, I don't know what bodies, I mean, I'm not.
Yeah, people are going to start to do stuff, but these are like photos like, oh, they were on top of the trailer and they pop up and this is where it was getting staged and they did this in Russia. So let me show you the CNN clip. It's only, luckily everything's a minute long now.
Yeah, nobody patience.
Yeah, there's a minute long CNN clip. And then I emailed Nick Thompson, who's the CEO of The Atlantic, and I was emailing him and I'm like, oh, I bet you maybe he put something up online. And of course he's like, oh my God, because he was working for Chris at the time at Wired. And he's the one who did the story about Federico Musto at Arduino. And Arduino was finally able to get back together and kicked a criminal out. So you see how like bizarre and weird this was when this like came across. I'm like, I have to find out more. And there's another part of the story that I'm not mentioning because it's unclear who programmed it and deployed it. It's a fun story.
Okay.
I'll just let you know that
Let's keep
talking
going.
to Bruce Sterling about this. So here's the clip, and then we'll play the response from Nick, and then I want Lamar to talk about some of these things on the other side. And obviously this is going to be a different show now. It's going to be shorter. So this is our main segment. And I'm curious what happens when we talk about this now, and then the rest of the open source community sees this and says, oh yeah, I remember ArduPilot from 20 years ago. What happened to that? This happened.
Incredible video has been emerging from deep inside Russia on Sunday following a large-scale coordinated attack launched by the Ukrainian security services, the SBU, military air bases inside Russia, sources have told CNN. Videos circulating on social media from Siberia show plumes of thick black smoke billowing out of targets in the region of Irkutsk, some 4,000 kilometers away from the Ukrainian battlefields. Other video appearing to show from the drones themselves the damage inflicted by this attack at the Belaya air base in Irkutsk. CNN has also been able to learn that the attack was launched from inside Russia, with one video appearing to show drones rising from a truck stopped near a highway. Now, more than 40 aircraft are known to have been hit, including strategic bombers and one of Russia's very few remaining surveillance planes. The Russian Ministry of Defense has confirmed that airfields across 5 Russian regions have been targeted and have called it a terrorist attack. There have, though, been no reports of any casualties, and that fires at those bases have now since been extinguished.
Russia must feel what its losses mean. That is what will push it toward diplomacy. And when Russia takes losses in this war, it's obvious to everyone that Ukraine is the one holding the line, not just for itself, but for all of you.
Most interesting thing in tech, 15 years ago, I was a young editor at Wired Magazine. Boss, lovely guy named Chris Anderson, was really into drones. He made one out of Legos. He started a site called DIY Drones. He left the magazine and he went to go start a drone company, 3D Robotics. I remember going to the roof of the building in Berkeley and watching the drones fly around and talking about how they could be used in filmmaking in the future. Well, the company grew and really hard to compete with the Chinese supply chain. Eventually, the company got outcompeted. Chris went on to do other things. Well, lo and behold, what happened? So on Sunday, the Ukrainian army launched a massive drone attack on Russia, took out a large portion of the Russian military. Talked about it yesterday in my video with these drones that were smuggled in at the roofs of trucks and then launched, crashed in, loaded with munitions. Well, it turned out, what were they using for their software? They're using ArduPilot, software created by Chris and his team way back in the day. Open source software nobody controls and is adaptable was powering those drones. And there are a couple of really interesting lessons from that. One is the power of open source. You can build open source tools, and because they're so adaptable and because the community can change them over time, as the use of drones expands, changes, twists, turns, who knows what it'll end up with. Second, it shows once again the main point of this, which was the asymmetry of the attack. Not only were the drones really cheap, they were using free open source software. Of course, in the United States, most people are celebrating this, but it's also a little bit reason to worry. As an article in The Atlantic points out today, China has been buying up lots of farmland by US military bases. Why? Well, maybe it's just a good real estate investment, or maybe it'd be a really good staging ground for a drone swarm attack. All right, that's the most interesting thing in tech. See you tomorrow.
Okay. And if you haven't already, sign up for his newsletter. It is good. So this is Let's Disappears. So this is a minute and 30 seconds of where you can see the drones coming in.
Yeah.
And it does make it to the plane, and then it...
Yeah, so what's interesting is you see at the bottom it says, no fix.
Yeah.
Because the GPS has been jammed.
And these are the alleged videos that are coming off to things that are getting...
I mean, I think this is real. I think, there's a low quality but good enough camera that's communicating with cellular. You're seeing it, it's got compression artifacts.
Yeah.
I'm
I'm not contemplating this as a fake. I'm assuming this is
but it's
real,
like it overlays on top, and it's doing this fail safe. I mean, I'll be honest, I haven't used ArduPilot, and but it definitely has this mode where it's like, well, you can set
see the burning plane. That's the other one. So it's going around. It's like, I need a target.
Why aren't they in a hangar? You just leave them out.
I don't know. And then there's apparently Russia does something to their plans to make sure stuff like this doesn't happen easily, but because it's inside Russia, it did. And they were using the cellular network from Russia.
Because so somebody there just bought generic SIM cards.
Yeah.
And
sorry, this is the video of them running around and there was no more planes to blow up.
Oh, he's like, oh no.
He's like, what am I gonna do? Oh, and the batteries die or something.
Yeah. Oh, and he says, because they're using 60 amps. And so you can see the batteries actually dying as we watch it. The bottom left, it was at...
Do you think they just go all the way? They're just go, because you're not going to come back.
Yeah, that's it.
You don't need to save anything.
I always have the story about it's like if you're making military stuff, you only have to have the battery or the RAM run until it hits the target. You don't have to... It doesn't have to come back. It doesn't have to run again.
Yeah. Okay, and then here's the other footage. This is the one. Okay, it goes up, finds a plane, and then it says, oh yeah.
Okay, so it's... Yeah, and then I think you can set waypoints.
So it finds it.
So this GPS, this does have a fix. Interesting. So this one, maybe because the battery isn't dead, you see the battery's 19 volts. But look, I don't know if that's true, but it says it's drawing 40 amps.
Does it need to do something like arm a weapon? How does it? So this is going to crash into.
No, I don't think there's any arming. I think the explosive when it
hits it goes.
There's a.
Okay. So I sped this up, and when you speed it up, it's like, oh wow, that just blew up. That's really happening here. So
Yeah, you say like, I want to go at full speed.
I don't think anyone's seen this footage either. This is stuff that I'm getting on the alter web.
Okay, and it's like, bam.
Bam. And
Yeah.
it'll say, oh,
No data. Oh, no.
all right.
What's interesting is that it's like I heard that there was this article was mentioning that there was a GPS jamming, but I guess they were able to get GPS. Maybe they were using GLONASS or maybe using Beidou or something.
Maybe Russia decides, well, why jam inside across from like the airfield?
Yeah.
How could they? They're like, there's no way you got here. What do you need that for?
Okay.
So here's some views of how they allegedly built it. This is like the second or third time now we're showing electronics. Now let's go to the send a link to people later news. So I emailed Chris.
Yeah.
And now that I think about it, I probably shouldn't email Chris. I probably should have said like, oh, you said everything you're going to say. You're not going to, because like, I don't think, like, what is there to comment? He said everything on like a LinkedIn post or like a X thing. It's like, I had no idea that was going to happen 20 years ago.
Yeah. I mean,
wild.
It's open source.
It's like, I think the quote was, I started this 20 years ago and now it's destroying the Russian Air Force. So here's the bad news, I think.
Okay.
There was a window of time when Chris was running a startup, had 3D robotics.
Yeah.
We were selling them on our website. Someone mentioned those were the good old days. And that time passed. And there was a chance to have a US drone maker. And everything turned into DJI. And that's another country that has the most popular drone. We had a chance. We could have done it.
A lot of people are using, I mean, not a lot of people, but in many cases, people who are using drones for military activity do use DJI. What's interesting is what's smart about these people who designed these drones is, DJI, I think we mentioned this, they work with governments to have no-fly zones. So that, if the GPS does get a fix and you're within this zone, it'll depower. And so they had to use an open source firmware that they knew did not have any gating or, blockading.
It's like people talk about like jailbreaking stuff.
Yeah.
Like AI. So anyways, if someone wants to change the current situation in the world, in the US, if you think drones are the future of warfare, which I don't see how you could think it cannot be, if you think America needs to have a point of view of this, if you think a drone getting, blown up is better than a person.
I mean, it doesn't matter. It's the future. Whether you
agree
like
with
it or not. Yeah.
I do think that there should be a serious conversation of like what's important to all of us and who's going to be making these things. And things are different. These can come up anywhere. And I don't think there's any stopping it right now. I think this is actually like the asymmetric warfare has happened in tech. So anyways, I hope you enjoyed that. Let's continue to talk about open source hardware and let's see which projects will be on the news 20 years from now. The Adafruit learning system, where you can learn how to make all this stuff and more. Ladyada, what is on the big board this week?
Okay, let's look at the guide.
Yeah, let me get rid of all this other stuff. Yeah.
Okay.
That's a gear switch.
Yeah. Mikey Sklar updated the Pi-hole ad blocker guide. So Pi-hole 6 came out. Very popular ad and malware blocking firmware that you run on a Pi Zero or any Raspberry Pi. And we have some code that just has a little display, and the display tells you how many ads you blocked and like the IP address, so it's kind of handy. And these has been updated today. We've also been updating older IoT projects that used the old actions system in I/O, like things that would trigger events, to use a new Blockly setup, which is we think much more powerful and easier to use to make more complicated behaviors. So that's that. And then Carter, we have like a lot of updated. Carter updated the nudes Uber guide to had a lot more information about like forward voltage versus current, and he actually characterized all of the different filaments and nudes that we have. So if you're like, we call them 12 volts, but then you can actually see the curve, which can be useful if you're trying to tune the current with a voltage and you're trying to figure out like what is the resistor I should use. We have a new guide from Tyler, who works on Adafruit IO. This is a Blockly Actions project that takes a barometer and logs it to Adafruit IO, so you have a history of the barometric data, but also plots it on the little analog gauge, so like an old style barometer. And then we have some new guides. Below you see the SEN66. Liz and Tim worked on that together. I think they documented how to use the SEN66 breakout board with Arduino using Sensorian's library, but they also wrote our library for CircuitPython and Python, so that you can, if you want to use a SEN66, which is a great all-in-one sensor, We covered it on INPI a couple weeks ago. Tim also wrote up a guide for the OPT 4048, which is our tri-stimulus color sensor, just has Arduino and CircuitPython code. And then again, some more updated guides to the right here for things that use Adafruit IO with actions. So you're just going to see a couple get updated every week to have the latest code. And then at the bottom, I think this is also new, the Motherwell Demos USB key set. This is really cool.
We're going to play that demo. We're going to play that demo.
Yeah, so this is like, if you've seen the like Motherwell Demos 1968 Doug Engelbart video, he uses like this cool like chording keyboard apparently in it, and it was like developed at Xerox PARC. And it's just kind of neat. We like, there's only like 2 in existence, and we don't have access to that, but like we just thought like, hey, let's try to 3D print your very own if you want to DIY recording keyboard. And then there was actually a thread on Hacker News about people who were like, I lost, motion in like one of my hands, and I'm going through surgery or something, and my hand's broken. How do I type with one hand? And I was thinking like, use this recording keyboard designed at Xerox PARC.
Yeah,
and
cool.
then I think last week we did the arcade button guide. Carter did like everything you need to know about using our big arcade buttons, taking them apart, modding them, hacking them, making custom overlays, etc.
All right. And then on Playgrounds, go check it out. You can see the Fruit Jam color checker. This is all the neat things that might be in Fruit Jam as we continue to develop that. This was the Fruit Jam Rev B prototype board that Sam was using to do this cool color checker. We've got encrypted mesh communication with thermal camera. That's neat. We've got a handheld Arduino console inside of a VHS type. These are all fun things. And
more.
You could do it too.
Okay.
Alrighty.
Put up your guides.
Yeah. Okay. So what we're going to do now is we're going to play a video from Noah Pedro. It's the recording keyboard thing. And then we're going to go right into NPI and a couple other stuff and then new products. See you on the other side, everyone.
You can build a reimagined corded keyboard inspired by Douglas Eaglebart's 1968 Mother of All Demos. This is a USB HID device that has 5 keys that can be pressed simultaneously in different combinations to type out full words and phrases. Original chording key sets are designed to be used the same way you would play chords on a piano. Ideally, this will let you type without having to move your hand. In our setup, we can press 2 or 3 keys to type out phrases while single key presses type full words. Our project features an Adafruit QtPy RP2040 running CircuitPython. Piano-style keys feature a hinged lever mechanism that strike low-profile Schottky switches. There's no custom PCB, just Schottky switches in an Adafruit QtPy RP2040. Our 3D printed snap-fit enclosure closely follows the mechanical design of the original Xerox Alto key set. At the top of the code is a dictionary where the strings and key combinations are listed so you can easily customize them. The keypad module in the USB HID CircuitPython library is used to handle the key presses. For a full step-by-step tutorial, check out the guide at learn.adafruit.com. 5 Schottky switches snap fit into a key plate that's secured to the base of the enclosure. A dowel is inserted through a hinge built into the keys and rests on a bracket. The QtPy is fitted into a holder that's secured to the base. We've also included a downloadable step file that you can import into open source CAD software like Blender and FreeCAD. Although the corded keyboard didn't quite stand the test of time, we hope this inspires you to get creative and build your own custom devices using CircuitPython.
All right, and don't forget the code is EtherWiz, 10% off in the Adafruit store all the way up to 11:59 p.m. tonight. Let's kick it off with some NPI.
On NPI.
Hi on NPI, brought to you by DigiKey. This week is Texas Instruments new product introduction, the greatest and latest new products on DigiKey. Ladyada from Texas Instruments. What could you possibly be showing us?
I know, they have come up with so many products. This week we're looking at the new CC 33,000 series, or 33XX series, because there's actually there's 4 different chips in this family.
I feel like today in particular, we're seeing a lot of things from the past.
This is a blasphemy of
The past, we might be done with the past. The past ain't done with us. The CC is back.
That's right. So this is CC33XX series is the simple link. This is a companion chip. It's not, you probably can program it on its own, but it's meant to be a companion to a microcontroller or microcomputer to add Wi-Fi 6, 2.4 and 5 gigahertz, and BLE over SPI or SDIO, plus UART for BLE.
It's an add-on chip, so it's kind of like, what's out there that's similar that people might know?
Well, I'm actually going to talk about what it's similar to. So, so this is the next generation of what was originally the CC3000, which was like one of the first, it wasn't the first Wi-Fi companion chip, but it was like the first low-cost companion chip. I mean, the price now is kind of nutty because there's like only 50 in like the universe. But at the time it was released, it was available for only $12 a piece, or like maybe $15 a piece. It was very inexpensive compared to many other modules. And so it was possible to actually make a little break. It's no longer made. Like I said, people don't, use the CC3000 anymore. But back in 2013, this was like the shit because you wanted to add Wi-Fi. There was no such thing as a Wi-Fi microcontroller at the time. It was, something you had to add on. And a lot of times people would actually like glue a Linux computer, which basically Arduino Yun is, and OpenWRT. There's a lot of projects where you would like take an OpenWRT board, like a little Linux router, and you'd connect it to your microcontroller to get like analog inputs or like rotary encoders. And then basically Yun is sort of like a miniaturized version of that. But like that's kind of like a big deal, and you often don't want to run a full Linux computer. There's a lot of power. There's this slowdown. You have to have like the interface. And what was really neat about the CC3000, it was like you could run it on something as small as an Arduino Uno with the 2K of RAM, 32K of flash, or any microcontroller basically that was popular. And you could do DHCP, you could do DNS lookup, you can do ping. This was like a really big deal. I'm trying to think, there was earlier modules, but yeah, they were like $50 a piece. It was very expensive to do Wi-Fi or Ethernet. And often they communicated over AT commands, which is a real pain in the ass. You could do stuff like send tweets. And this chip actually kind of powered like a massive ecosystem of low-cost IoT boards, like this Spark Core. This is like before the Photon, so it's called the Spark Core, and then Spark changed their name to Particle. So it's basically the particle core. And this was an STM32F something on the back, and on the top there was a CC3000. And this was like a massive deal. It was like, they sort of sold it at cost. It was like $20 or so, or $30. At the time, this was considered a very inexpensive IoT microcontroller that had like Wi-Fi and, microcontroller, and you could do USB.
Particle was called Spark.
Well, they changed their name,
Yeah,
and so this got updated. But this was, $670,000. It's like $500,000 for a Kickstarter. It was a very, very big deal.
Yeah, a long time ago too.
2013. And then this was, one of the things that was that happened was like, as that chip was actually very, very successful, they came up with more versions like the CC3100. And what this added, I think, was
GPS?
I think it added SSL. Yeah, I think it added HTTPS, and I think it added WPA2. It added a couple things to make it more useful because, you do need SSL. But they'd only added SSL like 1.0, I think. And you couldn't upload your own certificates. I think you had like only one certificate you could use or something. And so the next one that came out was the CC3200. And what was neat about this one is you could run code on it. Like it changed from the original CC3000 to had an 8051 in it, which is amazing. By now they had a Cortex Cortex M4. And so you saw boards like the Wi-Fi, which was like an all-in-one. This is a CC3100 or 3200 with a sticker on top, essentially. And you could run MicroPython directly on it, which at the time was a pretty amazing thing. It was very low cost.
Yeah, PyCom.
This was the original.
Yeah, the original. That's right. I totally forgot about that.
I know. All right, so we're talking about the 3300. Yeah. So now you've heard the whole history. There's all these families. So it's not surprising that they would come up with a new version, but they have, all these ones were like little incremental ones. I think the 3300 is actually a big enough update because, obviously I didn't cover the previous ones on INPI, but this one I think is interesting because first off, they bumped up to Wi-Fi 6. They added BLE. It has 5 gigahertz, not in the 3301 series. It's a 335 series. It's a little confusing. But they basically have, 2.4 gigahertz with or without Bluetooth. and 2.4/5 gigahertz with or without Bluetooth. And you're basically paying like 50 cents to $1 more for every little thing you add. But the pricing they made it is pretty aggressive, which we'll talk about in a little bit. Right now they're just selling the raw chip, and you can use the chip directly, and it's not too bad to use. As before, they have SPI, but they also have SDIO. SDIO is going to be 4-pin parallel. It's going to be much faster. You're going to be able to push, I think they said up to like 50 megabits per second through it. So maybe 50 megabytes. No, it's not 50 megabits. And they also have UART. That's what you're going to use for Bluetooth. And then they have coexistence and antenna selection. So you can just like plop this on, and then you do have to. So you'll need a microcontroller. Obviously, like this does have a chip inside of it, but like as far as I can tell, you can't program it. So you'll need SPI or SDIO plus UART, and we recommend the flow control so you can do HCI, BLE. And this is similar to like every other chipset. Like pretty much whenever you have BLE on something like expressive chip or like a Bluetooth companion chip or whatever, or even like a USB dongle, it's almost always using HCI, which is like a UART interface, and it communicates that way. Why they picked UART, I don't know, but Bluetooth did. This is how you wire it up, so it's not too bad. You do need some GPIO, but the analog front end isn't so bad. You need a couple capacitors, you need a power supply, you need one crystal, maybe 2 crystals if you want low power mode. Looks like you had like a balun in there. And then you just connect it to your antenna, and you can use a chip antenna, or of course you can use your RPSMA, whatever you want to connect. And then you're probably like, well, like I want like a module. And there is a module, but it hasn't been released yet. And I wanted to cover this before the module came out. But it is mentioned on the TA website that they're going to have the module. If you're wondering like what it looks like, they also have like a booster pack. So it's like that silver thing in the middle. And so you see, it's really easy. You just put, I think, like it looks like a crystal at the top, and then, like I said, you just connect your antenna.
Texas Instruments love making boards that have everything on it.
They do. But no, this is like their MSP430 booster pack thing. It goes with their dev kits.
Yeah, it does everything.
It does a lot, and I like how they have both antennas. So you can select which antenna. There's an antenna, a selector, so you can either pick antenna or external or internal. And for pricing, like I said, like the pricing is aggressive, which I like. So for the module. You can get the CC3301. That's the Bluetooth low energy with 2.4 gigahertz only. And it's optimistic, but they're like basically $290 for quantity 1000, like one reel. Ooh. And then the fancy 3351 module, so that's 2.4 and 5 gigahertz plus BLE, that's going to be $350. Again, this is budgetary. It's a little optimistic usually. It's not always available at that price, but it's like, we're starting to actually... the prices are very reasonable. It's within the other competition. So, we've covered other Wi-Fi chips here, and it's like...
When you say other competition, name one.
Well, I don't know. Like...
No, I mean like competition as far as like when you release a board
like Realtek has chips.
Yeah. And what are the ranges in there?
And they're going to be about $2 to $3. Yeah, okay, so it's within the range.
They priced it right.
Yeah, they priced it. I think what I like is that they stepped away from like the $10, $15 price, and they're like, okay, it's going to be like $3 to $4.
I would have expected this to be like $30 and been like, oh man, it's $30. Otherwise, I'd use it.
Well, I think because somebody actually mentioned to me that TI was like, they were like, oh, we have to compete, and so they're being competitive, which is good. It's good for the customers.
Yeah.
So you can add like a really good IoT for, $3.
Just to blend some stuff together.
And Wi-Fi 5. 5 gigahertz isn't always available on every chip.
And, just because it's in my mind, Texas Instruments is obviously a US company. If we want to see, an ESP32-like entity start to come out of the US in some way.
Well, I'd love if you could program the chip. I mean, it's a Cortex M4, a Cortex M4 with Wi-Fi. Yeah. 2.4, 5 gigahertz and BLE built in would be really sweet.
How many millions of ESP32s are out there? Right. So, I don't know. This could happen. This could work. Okay.
Right. So, so next up, you can download the firmware. There's a Linux kernel. So, in SDIO mode, you can connect it up directly to your Linux device, and it will act like, a Wi-Fi and Bluetooth interface, and the kernel will manage it. Or if you're a microcontroller user, they have an RTOS driver, and they have a driver porting guide, and they tell you here's all the functions that you have to implement. The timer, SPI write, SPI read, UART write, UART read, but they do have the driver written for you, so you don't have to do all of that work. And it's in stock, so you can pick up the chip right now. Like I said, the module's not available yet, but you could start developing with this. It's a QFN. It's not too hard to solder. You can make a breakout board, get started with the design, and then when you're ready to do your final and you want, a qualified module that's ready to go, you can bump yourself to the module.
Yeah. This is neat, and I'm excited to see what happens.
Yeah.
How many millions of little tiny devices are out this in the world?
I mean,
now?
everything. But what's interesting, I'll say something interesting. I've taken apart a lot of IoT devices, and a lot of them go with Realtek chips that have 5 gigahertz. 5 gigahertz is a very desirable thing. And a lot of low-cost IoT chips these days don't have 5 gigahertz. And so that's the kind of, Wi-Fi 6 and 5G, I think, is like, that's where they're really pushing the market, which is smart.
I see a lot of stuff because we're doing IoT stuff.
Like if this was 2 gigahertz only, I would probably not cover it.
Yeah, a lot of the IoT stuff that I have to use for our testing or in our home or something like that, when you install it, it says you have to have a 2 gigahertz network.
I know, but it's
in some form.
But that's going to end eventually.
Yeah.
You can't depend on it.
Yeah.
Some people, they don't control their Wi-Fi, and they're like, only the 5 gigahertz works within my location.
Yeah, and these are like pretty high-end things that are like, no, only 2 gigahertz. Okay, that's this week's Ion NPI. Exciting. This is like the classic Ion NPI, by the way. This is like, there's a module, Ladyada's going to do stuff, there's history. You're only going to see it here first. CC3000. Remember that? That was crazy.
That was
crazy. It's a crazy ride. That's Ion NPI.
On NPI.
All right, code is EtherWiz. We're going to go and do some new products. And then we'll do some top secret. Maybe we'll answer some questions over there. We have some questions in the chat too. Let's kick it, Ladyada.
Okay, first up, this is the INA 238. And you might be saying, didn't you just put in this product? No, I put in the INA 237, which sounds and looks a lot like it because it's actually like PIN and firmware compatible, but this is a slightly higher quality, so it's $1 more. If you need 5 microvolt offset instead of 50, and you want 0.1, input offset error, whatever, gain error instead of 0.5. I'm offering both versions because, again, it's firmware and PIN compatible. If you don't, pick the less expensive version. If you want slightly fancier, pick the fancier version. Next up is these heatsink tabs. I actually just was doing a lot of projects with these stepper drivers, and I was like, man, I really wish I had little tabs of thermal tape that were like kind of cut, ready to go. And they're 1/2 inch by 1/2 inch, which is, we have a couple heat sinks that are about that size. You can also use it for stuff like your, Raspberry Pi. So it fits nicely, gives it a little bit of passive heat sinking. Mm-hmm. They're just like pre-cut and very convenient.
Okay.
Speaking of heat sinks, we also have this non-fan version of the Pi 5, all-in-one anodized heatsink case. This is a beast. It's hefty. It's heavy, but it looks really cool. And this version, has a bottom, and you screw it together, and the whole thing is a heatsink, and it works quite well. We also put in last week the version with fans, so if you're like, no, I want a version with a fan. This version has a fan that you plug in. It's a little bit more expensive, but it has the fan with the internal fan controller, so it only turns on when it needs to be cooled. So both versions are available in the shop. Pick whichever one you want, with or without fan. They both have slots for all the connectors and stuff. One just spins and the other one doesn't.
Spinny?
Not spinny.
Not spinny.
Great. Next up, we have an update. So this is the Raspberry Pi computer kit. This is I just want HDMI cable, mouse, keyboard, so I can just get my Raspberry Pi up and running, like a companion to just the Pi. We got all new, better, lower cost mice and keyboards in, so I dropped the price, put these back in stock, so they're revised.
Once in a while in the world, prices can be lowered. I don't know if you knew that. They can go lower too. All right, want to do the star of the show? The star of the show, Ladyada, besides you, our team, the customer, the open source community, and always delighting and surprising one another. Whew.
Is a WizNet Wiz 5500 breakout. This was requested.
It was Ion NPI.
Was this? No. I don't know if I covered the. As soon as they come up with the next chip, I will.
Yeah. Lots of internet.
Yeah, it's IoT. Well, people like Ethernet because people trust wires. So the WisNet 5500 is really nice because it's SPI and it's got a lot of drivers available for microcontrollers. You can run it on a very small microcontroller up to like a high-end microcomputer. We have the Ethernet Featherwing and the Ethernet Shield, but there were some people who were like, well, I just want to like wire this up directly to some microcontroller board I've got. So they're cool. I'll just make a version that has level shifting and a regulator, and it has the mag jack. And you just like plug and play, you just connect it to your breadboard, and all you have to do is wire up the SPI pins.
Yeah.
And you have added Ethernet. There's also really good support in MicroPython and CircuitPython for it. So especially for those use cases.
And like, these other wireless devices are coming out, but if you need something reliable.
Well, some people certainly they want PoE, and you can use, we have PoE splitters in the store that you can use with this, that'll take a PoE line and split it into USB-C or micro B or DC jack and Ethernet. And now you've basically got like your little module that can sit out wherever, and you don't have to have a power line either.
It's cool.
Yep.
All right. Justin Barton. All right. Don't forget to code. It's EtherWiz. Now you know why. We're going to do some top secret, and then we're going to hit the questions. They're going to wrap up the show.
Okay.
Let's do it. Ladyada, I see your questions in Discord, y'all, but you can keep putting them there. And we also have the questions that we save. We're going to hit some top secret, and I'll see you over in Discord in just a few moments. All right.
So I did a bunch of prototypes this week. This is the most recent one. This is the IR presence motion sensors. This is like a PIR sensor, but it doesn't need a lens. So it's like really compact. It's a little bit expensive, but I saw people using it, and some people requested it because they were like, I want to do motion sensing, presence sensing without like a big PIR sensor. So this is an I2C sensor from ST. We're also doing a kit for people using microbits where they want to do like simple soil sensing, and they're using like this very inexpensive and simple NPN transistor resistive sensor. I prefer capacitive, but in this case, they really wanted the resistive. And so I was like, well, I'll just make a quick design based off of this kind of generic, like everyone has one of these. And so like, we're gonna have one too. This is an update to the DVI Pico Bell that we did for the Pico 1, but with the Pico 2, now there's HSTX, which didn't exist when I designed the DVI Pico Bell. So I've updated this to use the HSTX pins, which are a little bit different. And I also added like a USB breakout. I made the switch a little smaller and added 4 pins, like 2, data in, data out, power and ground. So you can easily add a USB port, because that's a really common thing people like to do when they have DVI. They also want keyboard or mouse. This is a common sensor that I just saw a bunch of people using for making magnetic potentiometers. It's a angle sensor, and it has both I2C and PWM output. I thought the PWM was kind of cool because it's just like you get a duty cycle output that ranges from 0 to 360, 360 out of 360. Then you just put a magnet on top or bottom and you rotate it, and it can just sense that angle that you're rotating it at. This is the latest prototype of the Fruit Jam, which I'm finally have time to work on now that I'm not doing tariffs all the time anymore. So
Look how much we got done in 1 week, by the way, everybody. Like, we got a lot done because we weren't watching hundreds of thousands of dollars of bills coming in endlessly. Things.
Yeah, I'm not a university, so it's like go fuck with them.
They lay off us for a week.
Yeah, they leave me alone. Go bother somebody else.
Go bother Columbia.
So that one, they fixed the Wi-Fi. It fixes Wi-Fi USB. I think it's the final prototype, so hopefully we'll get that in the show soon.
All right, and that's it. I'm not going to show this one. You don't.
No, don't show that one. I can't get it.
I know. That's it.
This is just a part of the Part of the Fruit Jam is I added an ESP32C6 as like a Wi-Fi coprocessor. And the Wi-Fi, the C6 is kind of the least expensive of the ESP chips. And so we've ported the Airlift firmware to the C6. And so I wanted to make a little breakout to make basically very inexpensive Wi-Fi for Arduino, CircuitPython, or I think MicroPython probably also has a driver for this. It's very simple SPI to Wi-Fi.
That's top secret.
That's top secret. Don't show that other thing. I can't do it.
I was doing emails and I'm like, let me ask some more if we should put this in as a joke.
Questions.
Anyways, let's do a question. If y'all can only see what's on my side of the screen. So let's do the questions. Anne made the graphics bigger. So
wow. That's great. Okay, do repeat shots align well? What, the slider, I don't see why not, because it's the stepper, if you have a stop location, then it's going to be the same every time.
Yeah, I think it should be fine because we use it for other things, so I think you'd be able to do it. I was talking with JP earlier today, for like, what do you do when you kind of record motion? And I saw someone, they called it performance mode. I'm like, that's a good name for it. I'm sure that's probably what everyone's calling it, but I don't know. I was like, that's handy. Next up, Adafruit. Can you set up one of these on the streaming camera and let us tweet MIDI songs at it? I'd love to hear this play on demand track some early Ministry or Metallica. I am going to ask Liz.
That would be actually a really
sending MIDI.
good idea.
That's a really good idea.
Yeah.
Yeah.
Especially if it was like, it had to be like a tweet, so it's like you had to fit it in like whatever. Well, Twitter's not limited anymore, but.
Yeah, but.
I should be able to like, can you send mods?
Yeah. Can you join nudes together with conductive thread?
You can. I would make sure it's like a really good stainless steel thread. I don't know how much. Yes, they only have a couple ohms of resistance, so I don't see why it wouldn't work.
Okay.
Go for it. Try it.
All right. Do you have anything for measuring 110 volt AC voltage current?
Well, I'm working on a board that can do it, but boy, it's I don't really suggest people deal with that kind of voltages. It's not my expertise.
Have you considered the XT60 connectors power circuits that exceed 2 amp rating of JSTPH? They are widely used in RC modeling and drones rated up to 60 amps. I hate screw terminals with a passion. They do open the possibility of getting polarity ring, another possibility of JSTVH rated up to 10 amps.
I'm actually really tempted to have something like you did, JSTVH. I mean, I've looked at a couple different ones, but the problem is, like I said in the video they're referring to, it's like there is this kind of standard of JSTPH already, which is what I've been using, but I'm starting to bump into situations where I'm like, what connector? Because the thing is, if I use like, whatever XT60 and you have JSTVH and I have an adapter, blah, blah, blah. And terminal blocks are annoying, but at least you can connect a pigtail for whatever you want. Yeah. It's like, I don't like them, but it's like, there's no really, like anything that's polarized is going to require an adapter.
Yeah. Good point in the chat. Someone says, oh yeah, by the way, if you do this, maybe it should be at Liz's place at midnight.
You should totally make it like right next to Liz's head.
Right. I am trying to make a low power e-paper display and I can't find any easy ways to do it with your displays. And she is also a guide for e-paper low power would be helpful. Well, you're asking for a really big project. So that's why there probably isn't an Uber guide that does it all. But Ladyada,
you can look at the MagTag design. That was really low power. Like you just cut the power when you're done and that was drawing like, 30 microamps or something.
We don't have a guide that says how to build an e-ink reader,
but you can just look at the design.
We have all the documentation for MagTag. We also have all the projects, and if you come on Ask an Engineer and you're working on it, probably help you out. If you get stuck, you can also post some forums. Okay. Let's go to the questions. There was just one that came in, I think, during the chat here in Discord. So let's see. Thread here. Question 4. Okay. We have this product, 1207, but we would be interested if we would come out with a low, high, and full speed support like using this. So is this that power question?
I think that it's only low and full, and they're like, well, there's a high speed one.
Oh, they want this.
Yeah, you can send it to me. I'll take a look at it. I know. Okay. Hey, look, can you just scroll down how expensive it is?
Let's see how expensive it says. Order now. Low emission isolated.
It's at the bottom. You scroll down.
Keep going.
Yeah, there you go. No, scroll up a little bit. It is $6. Well, it's not too bad. I'll take a look at it.
Okay.
It needs an isolated power supply too, I think. So,
Want me to email you the link?
Yeah, sure. I'll take a look at it. I know no guarantees, but it's a pretty recent chip too.
The questions and the suggestions that people are putting in lately.
60% of the people's suggestions make it to a product, by the way.
Fantastic. Well, you know what it is?
You filter out all the bad ones.
Yeah, so you know what it is? Now that a lot of the bad people are gone, we want to make sure you have a great time in this community. And if someone's being a jerk, you know what? There's plenty of other places for that. So they go there. And you know what? We don't give up, so they do.
Okay.
That's why we get good suggestions, because people know we listen and it's cool, and we're going to make it. That's it. We're going to make the things that you send us. The idea.
Stretching. All right.
That's how open source works. That is it. Thank you, everyone. This has been an Adafruit production. I'm pretty tired. It's been an exciting day.
Bye.
I'm going to play the outro video after your moment of Zener, and then I'm going to play a video by Aaron with our new toolkit because we've got so much going on. I don't have time to play every video, so I'll play a video when I'm packing up everything here. Here's your moment of Zener.
Hi, I'm Erin St. Blaine for Adafruit, and today I'm doing a walkthrough video of Ladyada's toolkit. This is a fantastic setup for beginners or for anyone whose kit just needs an upgrade. It's got a new soldering iron, some different holders, and lots of little components and bits and bobs that will really upgrade your makerspace. Whether you're doing prototyping or repairs or just trying to get to that tutorial, that really cool one you saw on the Adafruit Learning System, this kit will really get you started and launch you to the next level so that you can have a little less frustration and a little more success. Let's start with the soldering iron. A good soldering iron can truly make or break your kit. If you can't get a good solder joint, you're not going to succeed with electronics. That's just the bottom line. So getting a nice one is really worth the investment. This one's a cool one. It's got 60-watt adjustable iron with a temperature control box, so you can turn it up or down and get exactly the temperature you want to go with the solder you're using. It comes with a general purpose conical tip, which is great for most stuff, but it is also compatible with the Heiko tips. So if you want to swap it out with a different tip, that's really easy to do. It also comes with this very cool solder on iron stand. It's nice and heavy, and it has a little sponge in there already. So you can set it down, and that's going to keep you from burning your table. It was a long time before I got myself one of these, and I'm telling you, it's a game changer. And next up is my very favorite tool in the world. This is a pair of flush cutters. If you don't have any of these, if you don't know how great they are, it's time to get some. As you can maybe see on my wall back here, I have maybe 3 pairs in this office, one in my tool bag, one in my shop, one in my craft room. You know, I think I even have one in the kitchen. They are just wonderful for cutting really close to little corners, or cutting just, anything tight that you need to cut. And they're very accurate. I love these things, so definitely worth getting yourself a pair. Another absolutely essential tool for any soldering kit is a good pair of wire strippers. Now, if you're still using those ones that you found in your grandpa's garage in 1962, those are going to last you for the rest of your life, but you might have success with a new sharp pair. I like these a lot because when you squeeze them all the way, each of the holes is already measured and lined up, so you can get the correct gauge wire into your hole, and there's no accidental cutting like the ones where you have an adjusting screw. I like these a lot, and I like to have multiple pairs of these so that if I take them out on site or something like that, I've always got a pair of wire strippers. Next up, we have our solder sucker. So this thing is pretty useful if you ever mess anything up or don't get it perfect on the first try. If you get extra solder someplace it doesn't need to be, you could just press on this cool little plunger, place your tip down where it needs to go, and press the button, and it'll suck the solder right out of your project, leaving it neat and clean for a second try. Next, I'll show you the PCB holder. Now, this is one of those things that doesn't seem essential on your workstation, so I went for years without having anything like this. But now that I have one, I'm really excited about it. It's going to make my life so much easier. Here's how it works. You can slot a circuit board, or a microcontroller or whatever into these little slots here on the top, and it's got a spring-loaded action, so it's pretty easy to get the board in and out. And then everything's adjustable. So these little knobs will open up and you can slide these up and down, and it works really well for small microcontrollers or big ones, just to hold it really still so that you can solder and get the exact right spot with your work. Next up is our multimeter. So this is a really important thing to have in your kit. It allows you to sort of peek inside your project and see what's going on for troubleshooting or figuring out how many amps or volts you're drawing. It comes with a couple little probes and a 9-volt battery. The 9-volt battery goes inside, but it's a little tricky to figure out. You got to take this blue plastic case off first, and then take these 2 bottom screws out, and then the whole thing comes apart and you can put the battery in. You want to plug the black wire into the G hole and the red wire into this hole if you're measuring volts or continuity, and one of these two holes if you're measuring amps. The most unique part of this kit is the parts kit. So inside here, you got a lot of different little components. There's a solderless breadboard, which is a very cool piece of equipment. It comes with some little red and green LEDs. We also got some resistors, transistors, and some switches and buttons. Basically a lot of little bits that you're following your Adafruit tutorial and suddenly you realize, oh my gosh, I need a 100 ohm resistor. Now you have one in the drawer. So you don't have to stop your project. Because I don't know about you, but all the DIY electronics stores in my neighborhood have closed. And I don't want to wait 2 days in order to continue my project. So having a little kit like this on hand is really clutch when it comes to getting your projects done on time with as little frustration as possible. My favorite thing in the parts kit is this little solderless breadboard. If you know what these are, you know how cool they are. If you've never used one, you're in for a treat. It's actually a lot of fun. They are for prototyping. And all these little holes are connected inside, and then the holes along the edges are all connected to each other. So basically, as you connect one hole to another with these little jumper wires, you can make a temporary electrical connection in order to test your circuit and make sure everything is going to work. Right here, I'm going to do a quick little test with one of these LEDs and see if we can get it to light up using the solderless breadboard. Oh, look at that. So that's my walkthrough of Ladyada's toolkit. The whole thing is $100, so it's a really good deal for all the stuff that you're getting. And it'll really level up your game and level up your workspace. And after you get your tools, remember to check out the Adafruit Learning System for all kinds of projects and fun things to make with your new stuff. If you like this video, remember to subscribe for more fun tutorials and intros, and we will see you next time.
Learned